This video is about using the fundamental trig identities, and we're going to do two things. And the first, all of these problems are taken from your textbook, which is the 11th edition Barnett trig book. And the first example that we're going to do is to show that a given equation is not an identity. So to show that something is not an identity, you have to find one value, just one value of x, which is in the domain. It's defined for both sides of this equation, but that makes this equation untrue. So what I'm going to do is pick a value off the unit circle. So I'm going to think about, I'm going to choose this value here. I'm going to choose pi over 6, this angle value. And so if I think about my unit circle, the coordinates for this point on the unit circle, the cosine of pi over 6 is the square root of 3 over 2. And then the sine of pi over 6 is 1/2. So I'm going to evaluate the right-hand side of this equation. 2 times the sine of pi over 3 would be 2 times 1/2, because, pi over 6, that's what 2 times the sine of pi over 6 would be 2 times 1/2, because that's the sine of pi over 6, and 2 times 1/2 is the number 1. That's what that side of the equation is. Okay, over on the left-hand side, I'm going to stick in pi over 6 for x, so this becomes the sine of 2 times pi over 6, and that becomes the sine of pi over 3. So here's my unit circle, and this is where pi over 3 is, and the coordinates of this point here are 1/2 square root of 3 over 2. And so the sine of pi over 3 is, I know that's hard to read, but that's the square root of 3 over 2. So the sine of pi over 3 is the square root of 3 over 2. So what we find is that when we let x, I said let x equal to pi over 6. The sine of pi over 6 is 1/2 times 2 is a 1. If I put pi over 6 in this side of the equation, 2 times pi over 6 is pi over 3. And the sine of pi over 3 is square root of 3 over 2. And we see that this does not equal to that. Since pi over 6 is in the domain of both of these expressions, it's defined, and these do not equal, then this is not an identity. That is how you can show that something is not an identity. Okay, here's the second example I'm going to do about that discusses fundamental trig identities. It says find the exact value of all 6 trig values of x, and we want to write it in exact value. So we have to use the fundamental identities to do this. There are many other methods to find these, but what we're doing is practicing the fundamental trig identities. So they give us that the cotangent of this angle x is -3/2. And they give us that the cosecant of this angle is positive. So the first thing I'm going to do is think about which quadrant this would be in. So the fact that the cotangent is negative means that the tangent, which is its reciprocal, is also negative. Where is tangent and cotangent? Where are they negative? They are negative in quadrant 1 and that's wrong. In quadrant 2 and quadrant 4. They are positive. The tangent and cotangent are positive in quadrant 1 and quadrant 3 because it's a positive over a positive and a negative over a negative because it's sine over cosine. So I'm considering, since this is negative, it's either going to be in quadrant 2 or quadrant 4. So these are my choices, 2 or 4 right here. The fact that cosecant is positive, greater than 0, cosecant is equal to 1 over sine. That tells me that the sine also has to be positive. So where is this in quadrant 2 or 4? Where is the sine going to be positive? Well, it's negative down here. It's negative below the x-axis. So this means that we are looking, x has to be in quadrant 2 because the sine is positive, but the tangent is negative. So that was the first thing I did, was establish which quadrant it's in. Now I look at the given information. I'm given that the cotangent of x is negative 3 over 2, and I have to use the fundamental identities to find the rest of the values. Okay, here's one I can use. The tangent of x is the reciprocal of the cotangent of x. So it is just going to be negative 2 over 3. That is what tangent of x equals to. It's the reciprocal of the cotangent. So that one's good. It's out of the way. Now let's see, can we think of some fundamental identity that involves the cotangent of x? And we can. Here's one that I memorized. The sine squared of x plus the cosine squared of x is 1. I can come up with some other Pythagorean identities by dividing both sides of this equation by sine squared of x. And if I do that, I'll get sine squared of x divided by sine squared of x is 1. Cosine squared of x divided by sine squared of x is the cotangent squared of x. And 1 divided by the sine squared of x is the cosecant squared of x. And so this gives me another Pythagorean identity. And this one's going to be helpful to me because it has cotangent in it, and that's the value that I know. So I'm going to use this expression. 1 plus cotangent of x squared, negative 3 halves squared, is equal to the cosecant squared of x. Okay, so let's solve this equation for the cosecant. 1 plus, when I squared negative 3 halves, I get positive 9 over 4. This is equal to cosecant squared of x. I'm going to add 1, which is 4 over 4 plus 9 over 4, and that's going to give me 13 over 4 is what the cosecant squared of x is equal to. Now I'm going to take the square root of both sides, which is going to tell me that the cosecant of x is equal to the square root of 13 over the square root of 4, which is 2. Now, I would normally say plus or minus the square root of 13 over 2. However, they told me that this has got to be positive, so I know this is positive, and I've already established that I'm in quadrant 2. I know that's going to be positive because cosecant is related to sine, and that means the y value, and that means it's positive. So let's see, here's our third value. Let's find this. The sine of x is 1 over the cosecant of x, so this is 2 over the square root of 13. That is another trig value. The last one I gotta find is the cosine. So there's a couple of different ways we could go through this. I'm just gonna borrow this one. I think this is pretty simple to do. I know that the sine of x is 2 over the square root of 13, so sine squared would be 2 over the square root of 13 squared plus the cosine squared of x, and this is equal to 1. I'm going to solve this equation for the cosine. So that's going to be 4 over 13 plus the cosine squared of x is 1. I'm going to subtract 4 over 13 from both sides. The cosine squared of x is 1 minus 4 over 13. That's 13 over 13 minus 4 over 13. That is 9 over 13. That's the cosine squared of x. When I take the square root of both sides, I will get that the cosine of x is equal to plus or minus the square root of 9, which is 3, over the square root of 13. It's either going to be plus or minus. I'm in quadrant 2, which is on the left side of the y-axis, which means that this is negative. The last trig value I need to find is secant. The secant of x is the reciprocal of cosine, so this is going to be negative the square root of 13 over 3. So there's how you can use the fundamental trig identities to find all 6 trig values.